Look, it's no question that the SAT has some of the hardest math problems of all standardized tests for US high schoolers. Now, I was able to get a perfect 800 on the math section not once, but twice, and I hope that in this video I can prove to you why you can do the exact same thing without needing to be a math nerd genius, because I'm certainly not. I was never in any crazy math clubs, the Math Olympiad, and I didn't even spend that long studying for the SAT. So here's how this will work. I'm going to show you some of the hardest questions that have ever been on the SAT. Seriously, this isn't going to be one of those clickbait videos that says hardest SAT ever, but then it's just something that your third grade sister could probably do in her head, because I know you're getting tired of seeing those. These are seriously going to be the top of the top difficulty, as hard as the SAT gets. And I'm going to show you how you can solve all of them with simple math skills that you probably learned by 8th grade. And remember, the SAT is composed of questions that College Board ranks as easy, medium, and hard, with the majority of the questions on your test being easy or medium, even if you get the harder second math module. So, that being said, maximum you will see 5 questions of this difficulty on your math SAT. So if you can do these, the rest of the test will be easy in comparison. So I'm going to stop talking now and let's just get right into the questions. Okay, for this first problem, we see a rectangular pyramid has a square base with an area of 324 square meters. What is the surface area in square meters of one of the triangular faces if the rectangular pyramid has a volume of 4,320 cubic meters? So, pause the video right now if you want to try this problem for yourself, but if you're looking for the solution after you've gotten your solution, or you get stuck and you want to see how to solve this problem, then unpause after this and we'll go through the solution. Okay, so here is how you actually solve this problem. So we're told a rectangular pyramid has a square base with an area of 324 square meters. So even though we're told that this specific pyramid has a square base, a rectangular pyramid just means that the height of the pyramid doesn't have to match the side length of the square base. So this just means that if we imagine the height going up, it doesn't have to match the side length. So if this is just a quick sketch of what our pyramid might look like, then we could see it might look something like this if the height is more than the side length of the square base. So we were first told that the square base has an area of 324 square meters. So we know that the area of a square is going to be the side length squared. So the side length of the square base squared equals 324 square meters. Now just simply plugging this into a calculator, we can see that the side length has to be 18. So that means that for our pyramid, the side length of the base is going to be 18. Then it asks, what is the surface area in square meters of one of the triangular faces if the rectangular pyramid has a volume of 4,320 cubic meters? So basically what we're looking for in this problem for our actual solution is the area of one of these triangular bases. So how are we going to find that area? Well, we know that the general area equation for a triangle is going to be 1/2 base times height. So in this case, we know that the base of this triangle is 18, but what we're looking for to be able to solve for the area is going to be the height of one of these triangles. So the first step in figuring that out is figuring out the height of the pyramid. So we are given that the volume of the pyramid is 4,320. Now we know how to solve for the volume of a pyramid. It's just 1/3 times the area of the base. So I'll just call that B times the height. So in this case, I'll rewrite the 4,320 and the 1/3. And we know that the area of the base is 18 squared, or just 324, because that was actually given in the problem. So from here, we can actually solve for the height of the pyramid. So if you just do 324 divided by 3, then we get 108, and then divide 4,320 by the 108, and that gives us the height of the pyramid being 40. So that means that if we look at the pyramid basically from the side, and it looks something like this, then that means that this right here is going to be 40. And once again, imagine you're looking at it straight from this side, right here, then we know that this base length is 18. So this whole bottom is 18. Now, once again, we're looking for the area of one of these triangular faces. And what you'll notice is that we can't just use the height of the pyramid for the height of this triangle, because the height of the pyramid is straight up and down, whereas the triangular face is actually at a bit of an angle. So it's tilted back, so it's not going to have the exact same height. However, we can solve for the height now that we know these two values right here. So once again, imagine that you're looking at the pyramid from the side. The height of this triangle right here, basically this line right here, which would give us the height, like if we were to pull this triangular face out, we're basically looking for this height right here. Then you might notice that if you're looking at it from the side, it's going to be the length of this diagonal right here. So we can actually solve for this because it's just a right triangle. So in this case, this is what our triangle looks like if we're just isolating it out of the pyramid. We know that the height is 40, and then we know this base length all the way across is 18. And so for just this 1/2, it's going to be 9. And then if you actually just use the Pythagorean theorem, plug in 9 squared plus 40 squared, you get this diagonal length to be 41. So now we know the height of this slanted triangular face, and we can solve for the area. So we know that it's going to be 1/2 times the base, which is 18. And this time we're using the full 18 because we're looking all the way across here. We're not looking at just one of the right triangles over here. We're looking at the whole thing, so it's going to be 18, and then we just figured out the height is 41. And so when you plug that into a calculator, you get the area to be 369 square meters. And that's our final answer for problem 1. Okay, moving on, problem 2. The table shows the distribution of 88 basketball players and their positions on a basketball club. Each player is categorized in one position. If one of the 88 players is selected at random, the probability of selecting a player who is categorized as a power forward, given the player is not categorized as a shooting guard, is 3 out of 12. How many of these players are categorized as a center? So once again, pause the video right now if you want to solve this on your own, but when you're looking for the solution or if you get stuck, unpause, and here's the solution for this problem. So we know that this is a frequency table for the different positions of a basketball club, and we're told that if one of the players is selected at random, the probability of selecting a player who's categorized as a power forward, given that the player is not categorized as a shooting guard, is 3 out of 12, and ultimately we're looking for how many of the players are categorized as a center. Now you'll notice the issue here that makes this problem challenging is that we only have a combined frequency for powered forwards and centers. We don't have the individual numbers. So how are we going to find the number of centers individually? Well, we're going to use this first piece of information that they give us, which says that the probability of selecting a player who is categorized as a power forward is 3 out of 12. So anytime that we're looking to find a probability, we're going to have a fraction, and we know that the top is going to be the number of desired outcomes, and the bottom is going to be the number of possible outcomes. So the bottom is basically our selection size or our sample size. So basically, if you imagine rolling a 6-sided dice and you ask what are the odds of rolling a 1, the bottom is going to be 6 because there are 6 possible sides that you can land on, and the top is just going to be 1, not because we're looking for the odds of rolling a 1, but because only one side of the dice has a 1 on it. So in this case, if we imagine each player being a side of the dice, then that is going to be the bottom right here. But we have to pay close attention. It's not 88 because it says given that the player is not categorized as a shooting guard. So that basically just means that we're choosing from all of the players who aren't shooting guards, or in other words, 88 minus 16, because there's 88 total players and 16 of them are shooting guards. So that means that for this probability, our selection size is actually 72, and so that's the bottom of our probability. For the top, let's just call the number of power forwards P and the number of centers C. So we know that P plus C equals 35, and we don't know the individual counts yet, but what we can do is plug in a P up here because this is the probability of selecting a player who is a power forward. So we're using P for that variable. And so we don't know this exact value, but we are told that it's equal to 3 over 12. So this is the probability of choosing a power forward given that we aren't choosing a shooting guard, and we are given a value for that fraction. So we can actually just cross multiply here to solve for how many power forwards there are, or we can just kind of see the relationship here that we're dividing by 6. And so if we want to go back, we have to multiply by 6. And so we can see that the number of power forwards has to be 18. Okay, great. But ultimately, that's not what we're looking for. We're looking for how many of these players are categorized as a center. So we know that P plus C equals 35, and we just solved for the value of P. So we can rewrite this as 18 plus C equals 35, and then solving for C, we can ultimately get to the answer that the number of centers is going to be 17. And that's our final answer for number 2. Quick side note, if you're watching this video, then you'd probably be interested in my free SAT prep program, SAT Masterclass. There are close to 1,000 students inside right now improving their SAT scores for free, and you can join with just 2 clicks with the link in my description. Anyways, back to the problems. This next problem says, how many liters of a 30% chlorine solution must be added to 12 liters of a 10% chlorine solution to obtain a 15% chlorine solution? So once again, pause the video if you want to solve this on your own, and then unpause when you're ready to see the solution. Okay, for this one, I want you to think in terms of the actual amount of chlorine. So if we imagine the 30% chlorine solution as some amount of chlorine, not a percent of chlorine, but a total amount of chlorine, and then we add it to the amount of chlorine in the 12 liters of 10% solution, then that's going to give us the total amount of chlorine in the 15% chlorine solution. So that is a simple way to approach the problem, but now we actually have to solve the problem of figuring out how much chlorine is in each solution based on the percentage of it that's chlorine and the amount of liters in it. Well, think about it like this. If we have 12 liters of a 10% chlorine solution, then the amount of chlorine is just going to be 0.1 times 12. Because let's say that I give you 12 marbles and 10% of the marbles are red, then the amount of red marbles you have is just 12 times 0.1. Obviously that doesn't work out because you need like a whole number of marbles, but that's just how I want you to think about it. So for this first part, let's call this the 12 liters of 10% chlorine solution because we're mixing the 30% and the 10%, so those are the two amounts that we're adding up. So for the 10% chlorine solution, it's going to be the amount of liters, 12, times the percent of the solution that is chlorine, so times 0.1. Then adding to that, we're going to have the 30% chlorine solution. So the problem here is that we don't actually know how many liters there are, so let's just call that X. And then the percentage for that is going to be 0.3 because it's 30% chlorine. So once again, these are the total amount of chlorine. These are the total amounts of chlorine in the 10% solution and the 30% solution. It's just the total number of liters times the percent of the liters that are chlorine. Then on the other side, the combined one is going to have, well, how many liters is it going to have? Well, it's going to have 12 from the 10% solution and X liters from the 30% solution. So the amount of liters is going to be X plus 12. And the percentage that we're looking for is 0.15. Okay, great. Now you'll see that we actually have one equation with one variable X. So we can actually solve for X here. Now what I'd recommend is you can just plug this into Desmos and make sure you don't make a mistake. But if you want to see how you actually solve it out, all you're going to do is basically distribute everything that you can. So 12 times 0.1 is 1.2. Then we're going to have plus 0.3x equals, and then if we distribute this x, we'll have 0.15x, and then 12 times 0.15 gives us 1.8. So on this side, we will have 0.15x plus 1.8, and then we just rearrange to solve for x. So let's subtract 0.15x from both sides and subtract 1.2 from both sides. That will give us 0.15x equals 0.6, and then if you just divide 0.6 by 0.15, that gives us x as 4. And remember, x is the number of liters of the 30% chlorine solution from this part right here. That's the number of liters. And we just found out that it's 4, and that's actually just what we're looking for, how many liters of a 30% solution. So the answer is 4 for this one. Okay, so for this last problem, it says f of x equals 200 times b to the power of x. When x increases by 1, f of x increases by c%. Which of the following expresses c in terms of b? So once again, pause this video if you want to try to solve this on your own, and then unpause when you're ready to see the solution. Okay, for this one, I want you to think back to the most basic exponential or the mother exponential function that you're familiar with. For that, we know that f of x equals some initial population or amount, let's just call it L, times 1 plus the rate, because it's growth, to the power of t. So basically what this means is that if we have a 5% increase, so r is 0.05, and we go up or go forward 1 day, this power is going to go up one more time, and so we'll multiply the initial population times 1.05, which means it'll have a 5% increase. So let's write down actually what that means, because it'll be important. So for example, let's say that we have a 5% increase. That would mean that r has to equal 0.05. So this is going to be important later on, so that's why we're writing this down here. And in this equation, you can see that instead of t, we're using x. So this x here is basically just our t. So it's not really unfamiliar, it's just a different variable. And we're told that when x increases by 1, f of x increases by c%. And then we're just looking to find c in terms of b, which b is the thing in the parentheses right here. So to solve this, first thing we have to do is set b equal to 1 plus r. And that's because it's just the thing in the parentheses, and so we know that the thing in the parentheses for exponential growth is 1 plus r. So we solve for this. Now what we actually want to do is solve for this for r, so we're just going to subtract 1 from both sides. R equals b minus 1. So now to figure out r in terms of c, so that ultimately we can get c in terms of b, is look back to this example function again. So when r equals 0.05, there's a 5% increase. So what does that mean for if it's c? Well, if it's a c% increase, then we can see that r has to be basically 1/100th of that amount. Because if there's a 5% increase, then r equals 0.05. So for this example, we know that r times 100 equals c. And once again, that's because a 5% increase, where remember c is a thing in front of the percent, so it's already as a whole number. So like in this case, c would just equal 5. It wouldn't equal 0.05. So that means to get it to r, we actually have to multiply it by, or divide it by 100. And so if you go in reverse, you have to multiply r times 100 to get to the percent increase. So we can have this expression for r and c, and then rearranging for r, we will have r equals c over 100, because we'll divide both sides by 100. And then if we just replace this up here, we'll have c over 100 equals b minus 1. And then rearranging for the format that they have in the answer choices, we will have c equals b minus 1 times 100, which gives us d as our answer. So that's going to be it for this video. If you're looking for more help with the math section of the SAT, check out this video and be sure to subscribe to the channel for more SAT content. I'll see you in the next one.